Hey guys, welcome to my channel. Last night I did a video on this motor. For those of you who haven't seen my page or anything like that, it's a preview on the motor. This is two 1-inch magnets, steel core, and then this is the drive coil, and then I have a generator coil up here. Last night I did a video in this setup, except this is a MOSFET circuit with optical timing. And I was able to kind of defeat the Lenz law using a Bedini circuit, but not a lot of power out of it. But you can run a generator and actually use less energy just because of the magneto effect of that circuit. And if it's tuned right, you could get away with it. But this is more of a normal circumstance. I get a lot of questions about, why don't you put a generator on your motors to where you could backfeed it and try to run it for free basically. And if you could defeat the Lenz law in a regular sense, then I'm sure you could do that. But in this circumstance, as you'll see, Lenz definitely wins the battle. So what we're going to do is fire this up, and I have the output coming out of the circuit regularly through the capacitor discharger and then going to this battery, and then the generator is connected through here, full bridge rectifier, then it goes through an amp meter and then into the second battery as well. And we'll be able to see how much energy we could get out of the coil and see if it's actually helpful or not helpful, and that's what we're going to do. So here we go, we'll fire this up. This is not a self-starting motor. So what we're going to do is disconnect the generator. So we'll bring this up. So this is our usage right here out of the battery. And then this is the second battery voltage. And right now the normal output going through the capacitors is just discharging right here. So right around 5 amps at 16 volts. This one's set up for 16 volts, so 5 amps at 6 volts about every second or so. We're using about a half an amp, but this is not enough to run the generator, so we're going to speed it up. We just have a little 6-7 inch prop on there to give a little bit of a load. So let's just bring it up to 1 amp. There's 1 amp. So the generator core is just air, just like the drive coil. So there's nothing inside of it. It has, probably close to 5 times the amount of windings or more on it to get the voltage up enough to do something. So bring this up. So we're basically at 1 amp right now. So what I'm going to do now is I'm going to hook up the generator, and you're going to be able to see what it's doing. So there's the generator. So you heard the motor slow down a little bit. We're doing about 100 milliamps, and our amperage went up 100 milliamps. So it kind of cancels itself out, and then the motor's running slower. I'm going to disconnect it again, and you can see the difference here. So it goes back down to 1 amp. We're not using the generator. The motor sped up. So it's not really a very useful generator on this type of a motor. But what is useful is the output coming out of the circuit. So every time this turns off, we get a spike, and we'll charge up these capacitors and then dump it over there. So you can see this one pulsing. This isn't costing us anything. It's not really slowing down the motors at all. It's actually getting rid of all that excess energy in the system and putting it into a more usable form. So anyway, hope you guys enjoyed the video. Don't forget to subscribe, and if you have any questions, leave it in the comments. Thank you.